Hello all, welcome to my channel. Today we are talking about HTTP versus HTTPS. How websites talk and how HTTPS keeps it safe. So whenever you open a website like a Google or Amazon on your phone or laptop, this laptop or phone browser talks to Amazon or Google server somewhere on the internet. So this communication follows a simple rule called HTTP. It is a just way of sending and receiving data. So when you open your browser and type HTTPS and google.com or amazon.com, you are able to reach these servers somewhere on the internet using a protocol called HTTP. So HTTP means a protocol which has some set of rules. How can we transfer between client and server? So, example, when you search cricket score on your browser, asks the server, and the server replies with the results and you show on your browser. So, client consider as the browser or app, requests server here website or API, gives the response back. So, this request and response is HTTP request and response. So this request response cycle is how every website works, like YouTube, Instagram, Flipkart, everything they follow this request and response cycle. So via HTTP we can do request and we can get the response. So we client and server can talk each other. So the problem with this HTTP, everything is sent in plain text. So with HTTP, data is not protected. It is sent exactly as it is, like a open message. If you log into a site using HTTP, your username but password travel in readable form. So you and your bank website, you are trying to connect using HTTP and you are sharing your username and password. So that is a readable format like a plain text. So anyone on the internet can read this because there is no encryption. So they can read it like Wi-Fi owner or internet service provider or a hacker on the same network. They can read it, they can steal this information. So imagine you write your ATM pin on a postcard and send it through Indian Post. So anyone handling it can read it. That means a postman can open your letter, open your postcard, and he can read the text inside. So because it is a readable format. So when you connect it, so consider when you connect it to a public Wi-Fi like a coffee shop or railway station, and you are transferring some data, then they can read it. Internet provider, Geo or Airtel, they can read your messages. They can see your messages. Hackers on the same network, they can steal the information. And also man in the middle attack. So in public Wi-Fi, like airport or cave, the attacker can sit in between you and the website. So you are connected to a Wi-Fi in a Wi-Fi that is there in a public cave, and you are trying to connect this real website and attacker in the middle. So your data passes through the attacker before reaching in the real site. So they can read it, they can copy it, and they can quickly change it because there is no encryption. So even if you think you are directly talking to your real website, but your data may pass through this attacker first. So there is no guarantee of security. So they can steal the passwords and OTPs, they can change the bank account numbers, they can inject fake pages. This is why HTTP is unsafe for banking, UPI, shopping, login systems. So to overcome, we have few methods. So one of method is called encryption. So we solve this by converting data into unreadable format before sending it. This is called encryption. Only correct receiver can convert it back to normal text using a secret method. So to do this, we have uh, we have a method called symmetric encryption. So both client in the symmetric encryption, both client and server use the same secret key to lock and unlock the data. So consider you are the client. So from your browser is the client, and here is the server, google.com or amazon.com. You both have the secret key, same secret key, so that the client encrypt the data before sending to server, and server also has the same secret key. He can decrypt that particular encrypted data and he can read it. So the same secret key on both sides, so it is very fast. So they both agreed, like we both have the same secret key, we will encrypt and decrypt. We can easily transfer the data securely. So you and your friend, example, you and your friend agree on the secret key part before chatting on WhatsApp. So in real time, you and your friend, when you both met personally, you both shared a common word that you call it as a secret key. And whenever you start chatting in your WhatsApp, you put that word first, both verifies, then only you both start chatting the messages. The problem here is, in the internet, how can I how do you safely share that secret key over the internet without someone stealing it? That means, so client and server both are internet. So now we need to share the same secret key between both the client and server. That is the major problem here, because once we have this secret key, I can encrypt and decrypt, there is no issue. But how can I securely share this secret key between client and server? If I share normal using http, somebody in the internet, they can read this secret key, they can steal this secret key, and they can also encrypt and decrypt the messages I am transferring. So that is the problem. So to solve that problem, we have another method, asymmetric encryption. So in this asymmetric encryption, we have two keys instead of single key. We have two keys. So one is public key. It can be shared with anyone, like your mobile phone. Another one is private key. It keeps it kept secret, like your ATM pin. So now the client, here the server. Consider this is client, this is server. So server has two keys. One is public key, another one is private key. So when you try to contact this server, so this is your bank or Google or whatever it may be, then server shares its public key. So because public key can be shared with anyone, so it shares the public key. Now client also contains this public key. Now what client do, is client generates one random secret key. client generates one random secret key. So it generated one random secret key and using locked using public key. Locked using public key. Now client sent this locked message back to server. So now it's sent back to server. Server now can open this server can open this box using this private key. So now server also has the same random secret key because we locked. So first client sends a request to server has the public and private key. Server sends this public key back to client because it is shareable to anyone, and client generated some random key and it kept in a box and locked using public key and sends back to server. Now server has the private key, so he can open this locked box using public key. So he can open that locked box. So we client locked using public key, so server can unlock this using the private key. So server unlock this box and he can read that key. So now in both places we have same secret key and we transfer securely. Even if somebody in the internet, some attacker, they can read this. They can read this locked messages, but they cannot open because only private key can open this locked box, and that private key contains with the server. No one else contains that private key. So they can just see that message, they can just see that box, but they cannot open. So we solved the problem of sharing the same secret key in both client and server side. So now we are good. So only private key can unlock that box and they can read. So anyone can send you locked box using public key, but only you can open it. That means the server can open it. So this solves the key sharing problem on insecure network. So in HTTP is insecure. So insecure network, we solve the problem of key sharing. So now both sides the same key present. So now there is another problem, that is trust. How do you know public key really belongs to Google or your bank? Because when you try, so first time when you try to connect server, you received you received public key. That is fine. How can I trust this public key belongs to this particular server? Somebody can, some attacker in middle, they can create one public key. They can say like I am from this particular server, so this is the public key of that particular server, and they can send to the client. So I cannot trust. So that is the problem, that is the new problem we have. So attacker could fake a website and give you their own public key. So he can, if he send the data using that public key, he can open with his own private key and he can steal that information. So we need proper proof of identity, not just encryption. So encryption we solved here. Encryption we solved here. Now proof of identity is required so that I can safely trust and I can start the encryption and decryption things. So to solve that, we have the concept of certificates. So certificate is like a Aadhaar card for websites. So every website gets a certificate. How we get Aadhaar card? So similarly, server or website gets a certificate from certified authorities. So that like we if we get the Aadhaar card from the government, so somebody can trust like I am from India by checking that Aadhaar card. So here if we have some certified certificate, it confirms that public keys belongs to the real website like google.com or amazon.com because they have the certified certificate from certified authorities. So that's where the concept of SSL and TLS certificate. So those authorities, certified authorities, they issue a certificate. So they do some procedures. That is another process. So they issue a certificate like issue to they. So for one certificate, they issue to this particular www.example.com or google.com or amazon.com, and they say like this is certified by digital DGCET Global CA. We have different certificate providers, authorities. They also provide the certificates, and they give like public key and some valid date and some digital signature. So website name, that means like your domain name, www dot or whatever it may be. Public key, issuer, trusted authority. Issuer who is like it's a trusted authority. So digital DigiCert is one of the trusted authority. Similarly, like we have Let's Encrypt, and there are few more. So those are the trusted authorities, and some validity period also they give. So this certificate authorities is like a government office that verifies identity. So before how so government verifies and gives Aadhaar card to Indian citizens. Similarly, this certificate authority acts like a government office and it verifies the website and gives the certificate. So your browser already trusts many CAs like DGCET, Let's Encrypt. So certificate authorities take care of giving the certificate to website. So websites are servers, and your browser by default installs these DGCET or Let's Encrypt like from the certified authorities. So when you get the laptop, so these certificates already installed in our machine, so in our browser. So they check. So does this company really own this domain before issuing certificate? So who check? Certified certificate authority CS. They check whether before giving the certificate they do lot of checks whether this particular person is from the exact the website owner or not. So they check all the things and they give the certificate to your website. So how browser trust? So they get the certificate, that is totally fine. So no certificate authority gave a certificate to the website or web server. So how browser trust that? So very important. How does your browser knows which certificates are valid if it does not store every website in the world? That means every day so many websites they deploy and we can able to access it using securely, right? So how browser trusts this? Because it won't load all new uh, uh, we- website certificates, right? So it does not know all these websites. Instead, it only knows a small list of trusted authorities called root certificate authority. That means root certificate means like these are the certificates and the base certificates small list of certificate like from the trusted authorities. By default, we store it in our laptop or our system. So browser does not trust these website directly. It trusts who signed the website certificate. That means your browser. So client side, your browser, you have the some root CS that you get from digit digi, or let's encrypt. So you have these root certificates on your browser by default when you got the laptop. And these are the servers or websites. They also got certificate from same authorities. We have in between there are multiple steps, intermediate certificates and all those things. So ultimately they got one certificate. So this validation, everything taken care by the certificate authorities, and they gave the certificate. And when they send that certificate to you, you check the chain by chain, like intermediate certificate or intermediate certificates, and ultimately who is the provider of this certificate, root provider. So if the root provider is DGCert or Let's Encrypt, then you trusted that this is a valid website. So when you open a website, the browser receives a certificate chain and checks it step by step. So the same concept what I have explained. So website certificate example sbi.co.in or google.com or amazon.com. They signed by some intermediate certificate, and which is again signed by root CA, which is already in our browser. So if the chain leads to, so that means like ultimately if the both matches trusted CA already stored in our browser, the website is accepted. So if not, browser shows like a warning. Your connection is not private. That means if these two certificates ultimately doesn't match, then your browser directly shows like your connection is not private. So that is, this is how we have solved the trust issue. So now there is one more concept here called TLS handshake. So TLS is a system that creates a secure connection before data transfer starts. So before data transfer start between client and server, so we do some handshake. Earlier I mentioned we are connecting from client to server and server to sharing the public key and private key. So this connection we are doing the handshake, like this starts before transferring our data. So first time it do these connections, this handshake. Once everything is succeeds, then only it will start transferring the actual data. So that's why like TLS is a system that creates a secure connection before data transfer starts. It happens automatically in milliseconds when you open an HTTPS website. So the browser and web server, and I want a secure HTTP connection. When browser asks this website, and they say the concept I have explained, right? The CA certificate and asymmetric encryption. These two part of this TLS handshake. So it asked website, and here this web server, it also sends like here is my certificate, and you verify, like in your browser verifies with root certificates and verifies that certificate, and both create the same secret session key. This is using this particular concept I have explained here, asymmetric encryption. So once they trust, and then they key same secret key. same secret key for that particular session. So this is called TLS handshake. So asymmetric encryption is part of TLS handshake. So let's see, like browser says hello and shares like this is the methods I support and all the things, and service replies with its certificates and its key information. Both create a shared key using that asymmetric encryption. So secure connection is ready if everything like that certificate trust and certificate trust validation and session key created, then they feel like secure connection is ready. So after this, all the data, like whatever the login, payments, messages, everything is encrypted using this particular this particular key, this particular session key, so that both sides they can encrypt and decrypt that data. So HTTP yes equal HTTP plus TLS security layer. So HTTP yes means HTTP plus this TLS security layer. So we are doing trusting we are trusting and then we are creating session key using asymmetric encryption. So that is where we are saying like HTTPS is secured. So HTTP plain text, anyone can read it, no identity verification, data can be modified in transit, port number it by default it's port number 80, so no secure, not secure. That's a warning we get in our browsers. HTTPS encrypted, so TLS protected every byte, so every byte that we transfer, so it is TLS encrypted. Server identity proven by the certificate, and tampering is detected instantly if anything is modified. Like if you provide some fake certificate, it can easily identify like this is not given by trusted CA. So some tampering is happened, so it directly says like it blocks. It says like the warning that the port number for this HTTPS is 443. In your browser, you can directly see some padlock icon. That means like it's a secured. So the small icon in your browser means your data is encrypted and safe from the attacker. So quick summary. So HTTP data sent in plain text unsafe. HTTPS encrypted data safe. Encryption hides your data from the attackers. Certificate proves website identity. Certificate proves the website identity. Correct, right? So TLS creates secure connection automatically because using that handshake and all the things. So every time you see the padlock in your browser, a full cryptography system is working silently in milliseconds. So within milliseconds, all these things happened before starting actual data transfer. So this is how you can see like when you open so any website, Amazon.com or any other website, when you click on that, then it will, so in this icon on your browser, it will show like connection is secured with this padlock icon. So this is exactly like how we are saying how we are uh, how we say like HTTPS is secure. Thanks for watching.